Wow, okay, this looks really good. Okay, this looks really good. Okay, so today I'm going to do some freehand CAD, and in this video I share a couple tricks that will make you better at CAD and also help you do interesting things like making a vase. I also explore some pretty interesting features of Autodesk Inventor, so stick around for that, please. Okay, so today I just wanted to play a little bit around on CAD and just see what we could come up with. I've been playing a little bit with helixes and kind of making helical vases and different objects like that. So today I kind of wanted to try to just play with it and see what we could kind of come up with, just freehand. Sometimes I notice that freehand CAD is actually kind of fun. Now, this is if you know exactly what you want to do and you can kind of like formulate what you want to do beforehand, but here I think we're just going to sketch some sort of shape on the XY or ZX plane here, and then we're going to make a helical pattern upwards and see just how it looks. So in the past I've done something like where I take my circle here and I did a line pattern where I had a line, not tangent, but the sort of an angle off of it, and then I went back. And this was a 90-degree angle here, and it kind of looked pretty cool. And then I left a little circular cutout here so that when it was helixed up, it would have like a groove running down the little the curve, so that I could run a piece of filament through there. That's been a pretty popular 3D print that people have been doing. But for now, I want to see if maybe we could do just a simple hexagon. Maybe we could add more sides to it. So yeah, it's under the rectangle tool. Sometimes I still even have to play with it. So under polygon. So here we got our hexagon. Now for overall dimensioning, first of all, we'll just make that line just square. And sometimes I just play around with these two tools. These are constraints. Every once in a while, you may even see me do it. I'll click a vertical constraint, and because of how your camera's rotated, it'll just go horizontal or totally the most incorrect way that you did not intend for it to go. Sometimes you just go Control Z and it'll take you back. But I mean, for now, we got that. So this dimension is probably the easiest to control. Just so in real life, I got my caliper here. I'm just kind of eyeballing it. How big do I see this being? Maybe we make a small one today. So I'll go 2 inches. It'll be kind of a testament to see how well my printer can print. So there's that. We got 2 inches there. This is different than SolidWorks. Typically you're able to drag it. Maybe if I press escape, and then I could drag it. There we go. So we have that, 2 inches, and it's going to be 2 on all the other sides. Got a polygon. So I'm going to click finish here. And I believe we can go under 3D sketch and helical curve. Now here we could set where it's starting from, and then you see how I'm bringing it up like this. Now here we kind of can set the height, and then we also can set the pitch, which is going to be how tight each revolution is. You could think of it that way. How many revolutions per inch. So I'm just going to do a random number. How tall do we want the vase? That's really what this number is. So I'm going to go, again, with the caliper in real life, just opening it up. It looks like 4 inches might be nice. So it's a 2x4. Not really, but kind of. There's that. Diameter, I don't know if it matters too much. So the diameter of a helix. I'm going to go 2 just to keep it clean. And it's funny because that wasn't diameter. I believe it was radius. If we look on the top. I mean, yeah, that's probably an inch. That's probably an inch. No, I don't know what it is. That's kind of strange. Here it says 3.42 diameter. If we did 4. What is it picking off of first? Yeah, that's 4 inches. Interesting. Oh well. So I don't think the diameter matters too much, because you could just select it as a shape to kind of rotate this around, but I do want to open that up again. We could go under 3D Sketch, press the plus on the taskbar. That's what this entire feature is on the left side. Plus the plus sign. Here's our helical curve. We could right click, then we could click repeat helical curve if we wanted to do another one. Didn't mean to click that though. We want to click edit. So I'm going to make the pitch tighter. I'm going to go 2. And so did that actually make it tighter? Let's see. Let's see if we go 4. Did helical 4. Oh. For some reason the height of it just gets totally out of whack. Wonder if we go... There's no dimension. The helical curve. So there are different types. Pitch and revolution. We could also go pitch and height. That's, I guess, what I'm more so looking for. So under this option here, I selected pitch and height. Right here where my cursor is. Now I'm going to go a height of 4. So that's our 4 inches. And now our helical curve is kind of looking kind of wimpy here. Kind of wimpy. So we'll go... I think a smaller pitch is going to give us more revolution. So there we go. So that's going to be pretty crazy looking. But let's see. Finish sketch. Here's that. So we have our 2 features. And then what we can do is we can do something. I believe it's coil. If it's not coil, it's not revolve. It could be sweep. But I'm going to try coil first. So there's that axis. No, this doesn't look right. So it's not coil. I believe it is sweep. Yeah. So here's our profile. It automatically selected it. We could select a curve, which I believe... Yeah, I had to click here again. And we could just select that. And then it just kind of corkscrews up. I'm going to click OK and just see how this looks. Wow, that almost looks like... That literally looks like a thread. So that's extremely tight. So one of the nice things after you do this, and you might need a good computer, I'm going to be honest with you. Because what happens a lot of times is if you do this crazy feature, it might lag you out. And what will happen then is if you try to go in our 3D sketch again and edit that curve, you could totally bust your program. So I'm going to go ahead and save it right now. That is pretty aggressive there in my opinion. So what I do want to do is edit that. Straight up here we can't do that, but we can. So it's interesting, you can't edit the helical curve right there. You got to go into the 3D sketch, then you got to edit the helical curve. So we're going to go half as aggressive, finish sketch, and then it should adjust just like that. So that looks pretty good in my opinion. Neat. So thinking about the application of this is probably more so modern art, if you could even call it that. So one thing I'm looking at is the side profile here. So how steep is that? Could that be printed without supports? Because technically you would need supports. So if I'm just going to go ahead and sketch in one of these, because it's overhanging, you would probably see some support material that would like generate in that area. I'm gonna go ahead and click slice graphics. So this overhanging area would probably have some sort of support structure. That kind of looks like my terrible excuse for a sketch here, but something to bridge this gap so that this material up here has something to print on. And this would be of course removed after, but I believe that's not too aggressive. So if we go back into our 3D sketch and then edit our curve again, we can choose the option again. I think, no, they don't have a helical angle, excuse me. Taper is another thing that you could play with, but maybe I'll go 1. So it's gonna have 4 revolutions. No, it looks tighter. So we'll go back. Edit helical curve. Okay, let's see. 4. Should do 1 revolution. 1 complete revolution. Yeah, there we go. If we edit our helical curve and we make the pitch larger, we're going to have less threads per inch, or rotations per inch. So here we are. That looks a little bit more doable on a printer. That looks a lot less aggressive, to be honest with you, than what we had before. So this would probably print without supports. Another thing that we can do, and this is a fun feature, so we could go ahead and up here on the top taskbar, under modify, we could shell this out. Wow, so it actually has the internal. So it's doing a lot of math here. So I press OK. That looks kind of crazy. It's almost an optical illusion. Wow. That's pretty cool. But ergonomically, you would not really want any ridges on the inside of your pencil holder. So to keep it simple, I'm going to go Control Z, get rid of that. I'm just going to do a sketch on the top, and then I'm going to use one of the most overpowered, I don't know, OP things to ever exist in CAD, project geometry. I'm just going to tap that, and it immediately sketches that surface at the sketch plane, which is amazing because it saves you all the time of fiddling around with this, but I digress. Once you have that, go back to up here under the Modify tab and click Offset, and then it selects it as one whole sketch. So now we could offset it. So generally I do like 100 thousandths or 0.1 of an inch. So I'll do that here. That's going to give you a really, really nice border. In other cases, you could do smaller. But in this case, thinking about how small this is going to be, it's not going to be under extreme stress. You're not going to really need it to be resistant. I don't know, like a water bottle would be, a disposable water bottle. It's pretty flimsy, but like I'm talking about a reusable one. You can't really collapse those in. Maybe if you think about a medicine bottle, it's pretty strong. But I'm going to go 75 thou for now. Plus we're going to have the strength from each of these. One of my worries is that we're going to extrude into this side. You'll probably see what I'm talking about if it happens like that. Not rotate. Here we go. And I'm going to go down. And wow, that's pretty interesting. So maybe we had a magic number at 100 thou. That's what I was worried about. So we could just go Control CZ. And let's make it 0.15. Maybe we'll try 0.125. 125 thou. And then we can go to extrude, click that, still a little bit. Starting to feel like shelling it might not have been a bad idea in terms of ease of use, but 0.15. This should be okay. I don't know though, so we'll see. Yeah, that's not bad. So we know it's 4 inch tall. So how thick do we want the very bottom to be? Do we want it to be a little bit thicker so it has some more weight down there? It's not like this is going to be toppling over. It's pretty short. It's got a nice big base, but I don't know. What do we think? 3.75 would leave us with 4 minus 3.75, which is 1/4 of an inch at the bottom. That might be okay. So if we go to this, one of these planes, so a couple quick CAD tips. Taskbar, I call this a top taskbar. We have a bunch of different tabs: modify, create, explore, work features, patterns. I use patterns a lot. But on the taskbar on the left, if we click plus on this origin, it's going to give us the main planes. And these are very nice to pick off of. So what I want to do right now is right click. I want to have you visible. And then I'm going to make a sketch on you. This is just very temporary. And then I'm going to go over the sketch feature here on the left. I'm going to click right click, and I did this before, but for repetition, slice graphics. Boom. We sort of have a section view. Going through the middle of the part, because of how we initially designed it, we sketched the hex centered with this axis here, so we're exactly with half. I'm going to go back again. So let's see. There. Slice graphics. So now we could kind of see we're getting pretty thin here. And this is where it is as thin as possible. So what I want to do is make sure that this is actually able to be printed. So I could click, I don't know if I can. No, I can't. See, it'd be nice if project geometry could get this. But what we can do, I believe. Now, I typically would not like this, but this line you could snap to. So that's there, that's said and done. But this one is pretty difficult to snap to because it doesn't have any snaps. So you could zoom in, and just for the hell of it, I will bring the point to the left of that line. Then I'm just going to do a dimension here and see where we're at. So clearly to the left, which would make that feature smaller. So if we're okay with it being smaller than what the actual feature is, it's probably going to print still well. So 18 thou. For reference, now this is kind of just me rambling on, but for reference, 18 thou is very small. Now, if we think of a piece of paper or the thickness of a human hair, I mean, for reference, a piece of paper is 3/1000ths of an inch. That's 0.003. That's unbelievably small. And here we have 18, so that's 6 pieces of paper on top of each other. That's that thickness. You can't even measure it with, I don't know. I have this old, very physical caliper. It almost has the same units as what's on a ruler, the same precision. So it's not very good. It's very good for estimating things, but in general, 18 thou is pretty small. So in this case, I might offset it another 25 thousandths. And by it, I mean that extrusion into our little vase here. So what I'm going to do here is I'm going to go back into our sketch that kind of hollowed this out, edit the sketch. So right now we're at 150. I know I said I wish I was at 0.075 before, but it looks like we're going to be 0.175 now. So that should give us 25 thousandths more room to work with. And this looks pretty bulky here, but it should be okay. It's mainly an art piece, so I'm not too worried. And plus, this is all going to be hollowed out, so we could hollow this out in our slicer. It doesn't look too bad. Another thing, if your work planes, all your sketches get in the way, you could right-click, visibility off. And a lot of times for useless sketches like this, just delete them. And then we can keep clicking these on the sides and make it nice and organized. That's usually how I leave the file. I'll save it and it looks nice. Other than that, another good practice to get into if you're using CAD is to just kind of get this into a nice isometric view. And when you, in this software, in Inventor, if you use the view cube and you click it, it'll move it in a nice area. Kind of in the middle of your screen, out of the way. And then I would save it. And then this is where I would close my file if I were done with it. It just, the main benefit is when you open it up again, or if someone else opens it up, it's going to be nice and clean, clearly in view, instead of you having it like that. I mean, that's kind of a pain in the butt. Yeah, it's one click to get it back, but still, it's more presentable and it's more professional. So this looks pretty good. I really like this. Now, and kind of a side tangent here off of my entire video, which is a side tangent on making vases. In SolidWorks, there is a feature called configurations. And now with configurations, you could do a bunch of cool stuff. So, for example, this is my main part. I could create another configuration where in the sketch, in the initial sketch, or the helix, I make it, instead of 4 inches, 6 inches. And I could save that as a configuration, vase practice 6 inch. and then I can make a 8-inch derivative of it, and then a 10-inch derivative of it, and then I can make a 4-inch base, 8-inch tall derivative of the original vase. I could make a different configuration with a different pitch of the helix. You could just do a bunch of stuff. Make it not hollowed out. You could completely like suppress that extrusion feature in a configuration. Where that would be beneficial is you could make one type of vase that kind of has a nice style that you like, and potentially use different configurations to make different looking vases of the same type. That could possibly save a lot of CAD time instead of trying to make this all over again from the beginning, which if you look at the video now, it's been around 20 minutes. That could save a lot of time. So these are all things that I kind of want to play around with and see if we could come up with any strategies to maybe automate making vases. Wow. So we're automating the CAD process and automating the production of them. Interesting. So just looking at the show tabs, I'm only going to go on for another 5 minutes. I won't keep you long. iLogic. I don't know. Vase practice other. No way. Okay, so we have programming here. This is pretty interesting. What am I doing? I don't know. This is a whole, oh my gosh, classes. Okay, this is out of my realm. I'm a mechanical engineer, I gotta be honest with you. But what is this? What? Okay, coding within Inventor. If anyone knows how to do this, please throw a video in the comments. I'll watch it. And I'll see if we could do some pretty fun things with it. Because this is a whole other world of CAD. Now, save and run, automating it. What? No way. Okay, my mind's going crazy. It's very late right now, but... Okay. So, for this tangent, that's a tangent of the tangent of the tangent of making vases in this video. I know for a fact there's equations somewhere. Where is it? You could actually put functions and mathematical equations in, and I think you could have it model. There it is. Parameters? No, that can't be it. But there is a place that you could actually write mathematical equations, so like functions, natural log of whatever, and have it graph that line, and you could possibly make that part of your sketch. But to be honest with you, back on the topic of configurations, where you can have derivatives and other parts of the same part with the same features but different dimensions, this looks like it's it. Forms. So, under the Model iLogic tab, wow, that's a lot. I'm right-clicking. I'm not getting any luck here. So I'm just going to press Escape. Get out of that. It looked like 2D Sketch was highlighted. So we'll go to... not global forms. Forms. Right-click, Add Form. Yeah, I clearly don't know what I'm doing. Splitter. Wow. Okay, we'll stay in our comfort zone for now. For now. It doesn't hurt to learn new things, but I guess I can end this video off before 25 minutes with another life hack. So, other than leaving your part nice and professionally set up for the other person, which I'm gonna do now. That, save, that's looking good. I could close out of this. Another life hack is that you can just, this is what I do for a lot of things, vase practice V2, save. Here's our new vase. Where'd our extrusion go? Oh, it's on the other side. Here, let's scooch you over here. Don't know why it's saved like that. Probably because that's how I had it before. And now you could tweak dimensions. So, for example, quick example, we didn't want this down as far. We could do that. And now we have a different version of the vase. So, there's a lot of things you can do with CAD. Other than making vases, make literally anything you want. But just the overall ideas, I guess if you were to come away from this video with anything. Wow, my throat is dry. Hit the like button so I could buy some water. That'd be nice. But if you're coming away with anything from this video, it's that one, save your files before you do any big, high computing activities. I've lost a lot of parts like that, and it's never fun. Parts and time. So, constantly save. Name your files something that you're going to remember. Vase practice V1, V2. Even the V's might be a little bit unspecific. You might want to specify what makes them different from each other. 3. Keep your files clean when you open and close them. So, as we have it now. Leave it in a standard isometric view, clear in view, not off in a space miles away. Leave the design tree on the left, nice and concise, closed out, and save it. So that when someone else opens your models, they're nice and clean for them. These are small like idiosyncrasies that other people notice. Other people might not notice, but it's sort of the respectful thing to do, and it's good practice. So I would keep those 3 things in mind when you're doing CAD. I am planning on actually doing a more structured video very soon. And I think trying things out like this, especially for a new channel, might be good. Because who knows, maybe this is what you guys really like. But until next time, thank you guys for watching. Hopefully you enjoyed this long, drawn out video of me making a vase, which should not have taken around 30 minutes, but I don't know. Next time it might be quicker. Alrighty, thank you guys for listening and watching. If you got to this point in the video, go ahead and drop a "I made a vase" in the comments. Literally type "I made a vase" in the comments. That way I know you watched it all the way through. Okay. Thank you for watching. I'll see you later. Good luck with making vases or whatever else you're making. See you guys.